Have you ever stared at a glass of water and thought it looked perfectly still? That is the greatest illusion in the universe. If we could shrink down 1 billion times, we wouldn't see serenity. We'd see a mosh pit. Billions of molecules vibrating, colliding, and jittering with frantic energy. This slide visualizes that disconnect. The large, stable sphere represents the water drop we see, but inside, it is pure, chaotic kinetic energy. This invisible engine is what drives every physical property we experience. What happens when you heat a gas? You aren't adding a magical heat fluid. You are simply kicking the particles, making them move faster. Watch the simulation. As we increase the energy, represented by the progress bar, the particles don't get bigger, but they hit the walls harder and more often. This microscopic violence pushes the piston upward. This is the ideal gas law in action. Microscopic speed translates directly into macroscopic volume expansion and pressure. Think of a solid like a diamond or ice. It's not a block, it's a regimented army holding hands in a strict grid. This is the lattice. As we add energy, watch the connections. At first, they just vibrate. But at the tipping point, the melting point, the energy overcomes the grip. The bonds snap. The structure collapses. We transition from the rigid order of a solid to the flowing chaos of a liquid. The macroscopic puddle is just a microscopic crowd that let go of each other's hands. Chemistry is fundamentally a contact sport. Two molecules can sit next to each other forever and do nothing. To react, they must collide, and they must collide hard. Here, we see blue reactants entering the field. As we increase concentration, adding more particles, the statistical probability of a crash skyrockets. Watch for the flashes. Every flash is a successful reaction, creating a new product. We control the speed of chemical manufacturing simply by crowding the room. So, why does this matter? Because once we understand the connection between the micro and the macro, we stop being observers and start being architects. We can arrange carbon atoms into perfect hexagonal honeycombs to create graphene, a material lighter than paper but stronger than steel. We are literally building the macroscopic properties we desire, like tensile strength or conductivity, by placing atoms one by one. The future is not found, it is engineered.